Let's dive right in. We're going to look at load chasing for structural design. So just listen in on this. The structural design is performed by chasing the loads of the dead and live load from slabs to beams to girders, then on to columns and walls. And this is what you're going to have to do for your bridge. So pay special attention to this section here. The loads are then carried down to the footing or foundation walls and finally to the earth below. So let's take a look. So if we have in here, we have some beams, these thin members in here, and you could think of this as just a sort of the deck on a bridge going kind of this way here. We have these beams, the beams attached to the girders then attached to the columns, and the columns attached to the footings. So that's a little bit about what is going on. So I would suggest you take a screenshot of this and add this to your notes. Now this is an overhead view. So here was the these columns right here, these little I-beams, kind of looking at it from above. Let me go back so you can see them. That's these pieces here. That's what we're looking at, these. Now this area in between, maybe that's our design area, and we're trying to figure out either a floor frame plan or if you're trying to figure out road decking, then you need to know information about how much load these can support. So you need to know how much load each beam needs to be able to support. So I'm going to show you how to do that. Well, you look at your design constraints, and this says that there's 6 feet 8 inches between beams right here, and that they're 18 feet long. So next thing we need to do is figure out tributary area, and that is the beam span, or the length of the beam, times the tributary width. And tributary width just means how much or how wide is the area that it's supporting. So if you look at each beam supports halfway to the next beam. So it supports halfway to this beam here, and this black beam supports halfway to that beam right there. So if we go halfway in either direction, that's 3 feet 4 inches this way, 3 feet 4 inches this way, so you have 6 feet 8 inches tributary width, which is essentially just the width between beams. So that is our width, and our span is 18 feet. So then we multiply those together and you get tributary area. So you definitely need to make sure you have this in your notes. You're going to need to calculate tributary area. So our beam span is 18 feet times 6 feet 8 inches. 6 feet 8 inches is 6 feet and 8 twelfths. Remember, it is 12 inches in a foot. So 6 feet and 8 twelfths of a foot is the same thing as 6.67 feet. So if we multiply those together, we get a tributary area of 120 square feet. When designing beams, we're typically interested in the uniform load along this beam. So we need to know how much load is applied to each foot on this beam. And so to do that, we need to know the tributary width and the floor loading in pounds per square foot. And so we have a system like this. It says that the floor has to support its own weight of 40 PSF, 40 pounds per square foot, and a live load of 100 pounds per square foot. So maybe if 40 pounds per square foot, that's a square foot is not very much. 40 pounds is a relatively heavy load, so that might be like a concrete load. Maybe we're talking the decking of a bridge or something, although that might even be more than this. If you're talking about a live load of 100 pounds per square foot, if a car is driving over it at any one particular square foot, there might be a load significantly more than that. So what is the uniform load applied to this beam? If we add these up, we get 140 pounds per square foot. And then just to calculate uniform load, it's floor load times tributary width, and that is 934 pounds per linear foot. So write down PLF means pounds per linear foot, because that's a unit you're probably not used to hearing. So that is how we calculate uniform load along this beam. That is what it has to support. Once you figured out beam loading, then we have to look at girder loading. So with girder loading, what we have here is these two beams, this beam on the top and the beam on the bottom, they attach right to this column. So the girder is going to be loaded by this beam here in the middle and this beam here in the middle, the ones that are not attached to the column. So if we look at the girder, that's this one that's going from column to column, it's going to be loaded by half of this beam here and this half of this beam. So that's an equivalent of one full beam here and one full beam here. That's the full girder loading. So you could calculate that out by figuring out what the beam loading total pounds per square foot of this area right in here is actually going to be. Now that's if you want to calculate girder loading. Let's take a look at calculating column loads. If you look at column loads, that is the girder loading plus the beam loading from each of these edges. So in your notes, you should write out how to calculate column load, and we're going to figure that out. You have a tributary area in this. If we break this column down so that it's halfway between this column and halfway between this column here, we can figure out what the total area is that this column has to support. Because outside of this column right here is going to support the next area. So the tributary area for this is 18 feet long because it's halfway here and halfway to here. It's 18 feet long. And this distance is 10 feet, half of 20, and then 10 feet down here, half of 20. So we end up with 18 by 20, which is essentially just this length and this height, but we're kind of cutting it in half because we're going in the middle. So we have a tributary area of 360 square feet. So make sure you note calculating column loads. This is how you calculate a column load. And now if we figure out that the floor system has to support, again, 40 PSF for dead load and 100 PSF live load, then what is the column load for this particular column? So the total is 140 pounds per square foot, and then the column load is tributary area times total floor load. So tributary area is 360 square feet based on these numbers from here. That's the total area that this column has to support, and it has to support a total floor load of 140 pounds per square foot, which is 50,400 pounds. Now if you're talking about an edge column, maybe this one right here, then it's going to be half of that area because we're not going off here to the right. There's nothing there. So we only go in halfway and then out and down. So your area in that case is only 180 square feet. If we're talking about a corner one, then it's only a quarter of that area. So you got to really pay attention. It's not always going to be a full square. Sometimes if it's a corner column, like in a bridge, the corner edge of this bridge, it's only calculating a quarter of that right there. So that is loads and load paths.